Welcome to the basic Python part of Scientific Python. In this video we will cover some of Python's fundamentals. Before we start, thanks to Rüdiger, Christoph and Philipp, who created the lecture in 2020, which some of our content is based upon. Now let's get started. First we have the print function. If you successfully solved the first homework, you should already be familiar with this function. And so what it does is that it prints objects. Now you may ask what are objects, and we'll come to that in a second. For now we can see that we can print this hi message here and the number 1. And printing these things is not really interesting because their output looks the same as they look in the code. Things get interesting when we print our own objects. So here we create the class cat, and you'll learn about classes later. So for now you just have to know that we can create cat objects, and we can do that by passing a color argument, which will go into the initialization function and then be set as one of the attributes of our cat object. So here we create a blue cat and assign it to the myCat variable. What happens when we print our cat is that we see the type of object that our cat is. So our cat is a cat, and we also see the memory address of our object. And while this information can be useful for identifying objects, it tells us very little about the actual object. And so what happens internally when we use print is that the object will be turned into a string with the string function. So these two lines here are equivalent. And so to give our cat a nice output when it's printed, we override the dunder method string. Dunder stands for double underscore. And in this function, we define the behavior for when the object is passed to the string function. So now, when we print our cat, the cat goes to the string function. The string function calls the string method in here, and this will then return the color plus cat. So when we print the cat, we see blue cat. In the beginning we said that with the print function we can print objects. But now to answer the question, what are objects in Python? Well, in Python everything is an object. And that even holds for functions. So if we print the type of print, we see that it belongs to the class built-in function or method. The same applies for Python's basic types, which are integers, float, strings and booleans. So they are also all objects. And these types are quite intuitive, but just to make sure, let's go through them. So integers are numbers, more concrete, whole numbers. They can be either positive or negative. Then we have floats, also called floating point numbers. They are numbers with a floating point, so we can, for example, have 2.567. And then we have booleans, which are truth values that can be either true or false. And as we can see here, all of these basic types are instances of object. Now, what does it mean for something to be an object? Now, what it means for something to be an object is that it comes with certain methods. And these methods provide us with different functionalities. Even integers have a lot of these methods, which we can check with the dir function. And as you can see, most of them are dunder methods, so double underscore methods. And these dunder methods determine the type's behavior for built-in operators and functions. So for example, if we write 1 plus 1, then this will call the add dunder method. And so these two lines are equivalent. Besides the numeric types and booleans, we also have strings, which you probably remember from printing hello world. We can create strings by putting our text into double quotes. And we can exchange these double quotes with either single quotes or also triple quotes, as long as we don't mix them up. That will throw us a syntax error. And we can also combine them if we want our string to contain one of them, or maybe even two if we use the triple quotes. So here we can see we have a string that starts with triple quotes, then it contains double quotes, and then the single quotes. And when we then print our string, we see that it contains double quotes and single quotes. If you're coming from other languages, you might be missing the type character. And indeed, there are no characters in Python. Of course, we can still have strings with a length of 1. Okay, now on to variables. So far our objects or data were kind of temporary. Maybe we printed them, but even then after that they were gone. And to now get a hold of them so that we can do some further computations, we give them names. And with these names we can then refer to the objects. So when we write a equals 1, we can think of giving our object or integer 1 the name a. And when we then call a, it will refer to our 1. We can not only assign objects to variables, but also variables to variables. Here we can think of giving our object a second name. So we don't give the name b to a, but instead to the object that a is bound to. So if we print b, we also get 1. Now, what happens if we change our object? So we write a equals 2. Will that also affect b? No. And that's because we don't actually change the original 1. What happens is that we create this new object here and then give it the name a. So previously the name a was bound to 1, now it's bound to 2. And if you remember, we also bound the name b to 1. And so if we want to still have access to our 1, we can call b. But if we also give the name b to some other object, then our 1 is gone. And what happens to these objects that are lost is that they eventually get collected by the garbage collector. Now onto typing. In Python we can change the types of our variables dynamically. And so we say that Python is dynamically typed. In this example here, you can see first we assign a number to our variable, or we bind this name to this object. Then we bind the name to another object with a different type, and then the same again. To check the type of an object, we can use the type function. And so we see first the type's integer, then it's string, and finally Boolean. We also say that Python is strongly typed, because the actual objects don't change the type. So our integer will always be an integer, and our string will always be a string. Okay, so now we know how variables work. The information that is missing is how we can name them. And there are some hard syntax rules, such as that we're not allowed to start with numbers, or that we cannot use special characters, except for the underscore. And besides these hard syntax rules, there are also some naming conventions. And the most popular naming convention we can find in the PEP 8 style guide. PEP 8 stands for Python Enhancement Proposal number 8, and it's the official style guide that helps making Python code look similar across different projects. And so for your own coding, this might not be so helpful, but if you have to read other people's code or if you're working together on some project, it's really helpful. Because with the naming of a variable, we also convey its usage. So here for module name, package name, instance variable names, local variable names, and also function names, we use the snake case. So everything's written in lowercase letters and words are separated by underscores. Then for class names and exception names, the variable starts with a capital letter and words are also separated with a capital letter. And then we also have global constant names where everything is written in caps and we use the underscore. Okay, so we can create variables, we know how to name them. So now let's do something with them. And for that we can, for example, use basic operators. We start with numeric operators. They work like you would expect. So we have addition, subtraction, multiplication, the power operator, division, floor division, and modulo. If you're unsure what any of them are doing, just try them out. One thing that is noteworthy is that the type of the result may differ from the input. So here we can see a is 2, b is 3, so they're both integers. But when we divide them, that gives us a float. So this does not mean that a or b change to the type float, but we get a new object which is a float. Next up we have string operators. They also work quite intuitively. So the plus operator concatenates two strings, the multiplication multiplies a string. Note that this does not work for float values, and we can also not divide a string, at least with this syntax here. Then we have Boolean operators. These Boolean operators we can use to compare two things. For example, numbers. So we have the greater sign, greater equal, of course smaller, smaller equal, also equal equal, which checks if two things have the same value, and then also not equal. We can also use the Boolean operators or, and not to perform logical operations on Booleans. So in this code piece we save the result of these Boolean operations, so the comparisons, which gives us Booleans, and then we use the Booleans to perform logical operations. Finally, we have the is operator. The is operator checks if two objects are identical, so if two variables refer to the same object. And this is not to be confused with checking if two objects have the same value. So even though we assign 300 to A and 300 to B, A is not B. But if we then assign A to B, so now B is also pointing to that 300, and then we can say that A is in fact B. Internally, the is operator checks for the object's IDs or memory addresses, which we can access with the ID function. And this ID function also appeared when we printed our cat. You might remember that printing the cat without the string dunder method gave us this weird memory address here, and that's actually the ID of the object in hex format. Okay, so what have we learned? We know how to print stuff, including our own objects. For properly printing them, we sometimes have to override some stuff, but you'll learn about that also later. We learned about different types: integers, float, strings, and booleans, and we saw they're all objects. Associated with every object are methods, which we saw by running the dir function. We learned how to create strings and that we shouldn't mix up the quotes. We learned how to get a hold of our objects by naming them. We know how to check the type of an object and also how to properly name our variables. And then finally, we have learned some operations that we can apply to our objects. On a general note, you really don't have to memorize all of these operators, or in general, most of the stuff we teach. The important thing is that you know what's possible and how to look it up if you want to use it.